first theory that can be used for ductile material is the maximum shear stress theory, MSS. Okay, and this theory, we suggest that maximum value for shear stress is limited by half of yield strength. So if we start with a specimen that's subject to tension only, that means we have stress in only one axis. We don't have stress in vertical axis. So sigma 1 has a value, sigma 2 is 0. So if you draw more circle for this specimen, it will give you a shape like this, with sigma 1 here is the maximum stress, sigma 2 is 0. According to Moore circle, maximum shear is the extreme value at the top and at the bottom. So as you can see, the value of sigma 1 is the diameter of the circle. Value for maximum shear is the radius of the circle, which means maximum shear equals half principal stress. And if the limiting value for principal stress is yield strength, then maximum shear is equal half yield strength. Which means if I exceed half yield strength, failure will start. So yielding begins when maximum shear stress in any element exceeds half of yield strength. Okay, so in calculation, you need to calculate that two non-zero principal stresses. From previous lecture, you know how to calculate two principal stresses. And I said there will always be third stress that is 0. So you have three stresses. Two you can calculate, and the third one is 0. So you need to satisfy this arrangement. Okay, maximum shear can be calculated if you have maximum principal stress and minimum principal stress. So you need to identify which stress is sigma 1, which stress is sigma 2, and which stress is sigma 3. Okay, now let's add factor of safety. We add factor of safety so we don't reach yield strength. We always want to be in a safe zone, or there's safety margin before we reach yield strength. So this will be your formula. So sigma 1 and sigma 3 are compared to half yield strength. So we have three situations. We have three cases when you calculate the two principal stresses, two non-zero principal stresses. You will either get two positive values, that's case 1, or one positive and one negative value, that's case 2, or three negative values, that is case 2, case 3. Again, you need to satisfy this formula. So for example, if you get two positive values, you get, let's say, sigma 1 was 150 positive and sigma 2 was 250 positive also. As I said, you always have third stress that is 0. So now you have three stresses. You have 150, you have 250, you have 0. Do this arrangement. The largest one is 250, and then the 150, and the third stress is 0. So sigma 1 will get the 250 value, sigma 2 is 150, and sigma 3 is 0. We only use sigma 1 and sigma 3. So for this case, when you have two positive values, sigma 3 is 0, and your formula will be reduced to this formula. And of course, you can add factor of safety. The same thing can be done to case 2 and case 3. Case 2, we have positive and negative values. So sigma 2 in this case is 0. sigma 1 will be the positive, sigma 3 will be the negative value, and then this is your formula. Case 3, two negative values, so sigma 1 is 0, because now 0 is larger than the two negative stresses, and then you use sigma 3 only. You don't use sigma 1. Okay, so this is the shape or the safe envelope, safe region for maximum shear stress theory. So we have a modification here and in this quadrant and for and this quadrant when we have positive and negative stresses. That is case 2. Okay, in case 1 we only look at maximum stress, which is sigma A, and in case 3 we only look at the largest negative value, which is sigma B, or the largest negative value or the smallest stress. Okay, so in maximum shear stress we have safe envelope. Any point inside this envelope is safe. If my point, a combination of points outside this envelope, then failure is expected. As you can see, this, if we compare this with practical experiments, we see that we actually have some still safe zone that can be added to the safe envelope. Failure didn't happen in these areas, and in some cases we need to use that area. In some cases factor of safety is very small and we need to use that area. So the second theory is distortion energy is a modification of maximum shear stress theory, and this theory we add this safe area